guys, in this video we'll be learning how to solve equations that have more than one variable. Now, in the past, we have just solved equations with one variable. Today that will obviously change. Your heading for today is solving multivariable equations. Solving multivariable equations, lesson 1.5, and be sure and include today's date. Alright? Solving multivariable equations, lesson 1.5. Be sure and include today's date. If I go too fast, pause the video, okay? Moving on. Now, first understand that when you are solving a regular single variable equation like we've done in the past, you are solving for numerical answers if they exist. For example, an equation like this. 2x plus 3 equals 5, bring the 3 over, make it a negative 3. 2x equals 2, divide both sides by 2, x equals 1. That is a regular, single variable linear equation, and there's the answer. Now sometimes they don't have answers, but we'll worry about that later. But those are the equations you've solved in the past. Your answers were numerical. In the equations we will be looking at today, multivariable equations, your answer will be an expression, not a number. You will see this when we start working problems. For example, you might solve for x and get something like this. Okay? That's an algebraic expression. I mean, look, you solve for x. X equals this. It equals 2y minus 6a. But it's not a numerical answer. It's an expression. So the equations we're going to solve today will have answers somewhat like this. Here are the, sorry to get you excited there, my bad, 7 steps that you will need to solve multivariable equations. 7 steps. Now again, I ask respectfully that you copy these down and don't use them if you don't like them, okay? But I'm trying to teach this in a way that reaches everyone. Here are the 7 steps. I will go through them quickly and I will pause at the end for you to copy them down. In fact, the 7 steps are really the 6 steps you just learned for solving linear equations, except for one extra step. So really it's not that bad. Simplify both sides. Eliminate fractions and decimals. Simplify both sides again. Move all variables. Now here's a little different. Notice it doesn't say move all constant terms to one side and variable terms. Copy this down carefully. Move all variables. That should be terms. Sorry guys, I'm having a consistently bad day. Sorry. Move all terms to one side that contain the variable you are solving for. Move all other terms to the other side. And please forgive my mistake there, okay? Now when I go to the next screen, that word term's going to disappear, but you know this is terms and this is terms, okay? Alright, so simplify both sides. Eliminate fractions and decimals. Simplify again. Then after you've done that, you want to move all terms to one side that contain the variable you're solving for, and all other terms to the other side. I will explain that step later. I will explain it well so you'll understand it. Okay, so don't worry about that. Simplify both sides again. Factor if necessary. That's the new step that you've not seen before. Factor if necessary. You don't always have to factor. Divide by the coefficient. Okay? And really, well, we'll leave it at that. So I'm going to pause. I'm going to sit here and be quiet, which as a teacher is probably difficult for me to do, to actually be quiet. But I'm going to try to do that, and I want everyone to finish copying down these 7 steps. Sorry, I hit a button there. Simplify both sides. Eliminate fractions and decimals. Simplify again. Move all terms to one side that contain the variable you are solving for. Move all the other terms to the other side. Simplify both both sides again. Factor if necessary. Divide by the coefficient. If you're not done with this, pause the video, okay? Let's take a look now at 5 examples. I'm really being consistently bad today. Let's take a look now at 5 examples that hopefully will help you better understand what we're trying to do today, okay? Here's example number 1. Okay, here's the first problem. And let's see if we can make this a little bigger for you guys. Alright, here we go. We're going to simplify both sides. Well, first of all, whenever you're given a multivariate equation, you have no idea whether you're solving for x or y unless you're told. So always look what you're solving for. In this case, we're solving for y. So we're going to get y all by itself. If you don't want to use these steps and you know what you're doing, that's totally fine. Step 1, simplify both sides. This is an x term and a y term. They're unlike terms. You cannot combine them. Here's a constant term, nothing we can do. Eliminate fractions and decimals, there are none. Simplify again, nothing to do. Now, move all terms to one side that contain the variable you're solving for. So, here's a term, here's a term, here's a term. Which one of those 3 terms contains a y? Because that's what you're solving for. Do you see what I'm saying? You're solving for y. So go through and underline all the terms that contain a y. That one does. So you want to get this term all by itself on one side and get everything else on the other side. Well, since the 2y is already on this side, let's bring everything else over to the other side. Well, the 7's already here. I'm going to bring the 5x over and make it a negative 5x. It was a positive 5x. Now it's a negative 5x. Now, that's step 4. So what you do is you go through and look for all the terms that contain the letter that you're solving for. And all of those terms go on one side, and all the other terms go to the other side. Do you see what I'm saying? Okay? Alright, now, simplify again. Well, on this side I can't simplify. Over here I've got a constant term and an x term. I cannot combine them, so there's no simplifying I can do. Factor if necessary. Let me go ahead and tell you now, we're only going to have to factor today on the last problem. And so when that happens, you will see why, okay? So until then, don't worry about this step until the time comes. And when the time comes, and once we have to factor, I will then show you how to know when you have to factor. But until then, don't worry about it. We will not have to worry about this step until the last problem, and I will show you then how to recognize that situation, okay? Last step, divide by the coefficient. Well, my coefficient is y, so I divide each term by the coefficient, each term. So these cancel, and I'm left with y equals 7 over 2 minus now, or negative. Now, I had a positive divided by a positive. That's why this stayed positive. I have a negative being divided by a positive. Negative divided by a positive is a negative 5x. Now I know I'm finished because y is all by itself. And that's what I'm solving for is y. Now that's pretty simple stuff, not too bad, okay? Let's try it. Let's try another one. Let's take the exact same problem, now let's solve for x, okay? So let's take the same problem we just had, let's solve for x. Step 1, we're going to simplify both sides. There's nothing we can do. These are unlike terms, and I have one term over here. Get rid of fractions and decimals, there are none. Simplify again, there's nothing to do. Now, we're going to move all the terms to one side that contain an x. I'm solving for x. So underline all of the terms that have an x. Well, I see this one. So I want 5x all by itself on one side, and I want to bring the 2y over to the other side. So when I bring the 2y over, it's positive here, it becomes negative. Simplify both sides again. Well, there's no simplifying you can do. I have one term here. I have unlike terms here. Factor if necessary, don't worry about that. Divide by the coefficient. My coefficient is 5. These cancel. I'm left with x equals 7/5. Negative over a positive is negative 2/5 y. There we go, we solve for x. If I'm going too fast, take advantage of the video, back it up and watch it again, okay? Number 3. This one's going to be tougher than what you think. I mean, it's almost so easy, it's difficult, okay? So please take some really good notes and pay attention here. Alright, we're solving for a, little a, not big A. We're going to solve for a little a. Alright, here we go. Simplify both sides. Well, first of all, don't become confused, students. Are you listening to me? This right here, pi AB is one term. Mr. Error, that's one term. Yes, that's one term. Positives and negatives are what divide up an expression into terms. If you had pi plus A minus B, that would be 3 terms, okay? If you had pi plus AB, that's 2 terms. That'd be 1 term here and 1 term here. Got it? If something's multiplying, there's still 1 term. So all of these are multiplying. There's no positive or negative signs. That is all 1 term. Please don't forget that. That's very, very, very important. Alright, simplify both sides. Well, I only have 1 term here and 1 term here, so there's no simplifying I can do. Eliminate fractions and decimals where there are no fractions or decimals. Simplify again, nothing I can do. We're going to go through all these steps and do nothing. Watch. Move all terms to one side that contain the variable you're solving for. Well, we're solving for what? A. Underline the term that has an A in it. This one has an A. Well, look, isn't this term already all by itself on one side? Yes, it is. Are not all the other terms on the other side? Yes. So that step's done. Simplify both sides again, nothing to do there. Factor, don't worry about that. Divide by the coefficient. Now here's where it gets interesting. In the past, you're used to a coefficient being like the 2. And I've taught you that. And really, coefficient's not the right word to use here because a coefficient is a number. Let me say that again so you're not confused. This is really the wrong word to use here because a coefficient is a number that's next to a variable, okay? But I've used this for lack of a better word. So if I'm trying to get A by itself, then what 2 things, if you will, would I want to divide by? Pi and B. In other words, look at it like this. Pretend I took this pi AB right here. If I rewrote it like this, pi BA, that's the same thing, they're all multiplying. I could divide by pi B and divide this side by pi B. Now some students get confused here and they're like, Mr. Earhart, why not just move the pi over and make it negative? Move the B over. No, 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 no. I have never taught you that. When we were up here in this problem, right here, and we got ready to move the 2y over right here to this side, did we bring the 2 over? Now watch. Did we bring the 2 over and make it a negative 2 and then bring the y over and make it a negative y? Absolutely not. Why did we not do that? Because that's 1 term. You can't just split up a term because you feel like it. The only way you can split up a term is if you do what to it, remember? Divide. So don't get confused. This is 1 term, guys. You cannot split. That's why I keep stressing to you. That is 1 term. 1 term, okay? You cannot just split up a term by moving parts of it. The only way you can split up a term is if you divide. So I want A by itself, divide by what? Pi and B. But if you divide one side by pi B, divide the other side by pi B. So your final answer is A over pi B equals, these cancel, leaving you with A. You know you're finished because A is all by itself, okay? Alright, not too bad. Excuse me. Okay, now, if you want to turn your books to page 32, I would encourage you to do that, okay? We're going to actually look at a word problem here. That's a multivariable word problem, so I'll pause a second while you turn to page 32. This formula, by the way, is called the Pythagorean theorem of baseball. there any baseball fans in this class, you might not have heard of this, but it's called the Pythagorean Theorem of Baseball. And it's a formula that gives the ratio of the number of wins to the total games played. And it's really interesting how pretty accurate it can be. Okay, and so by now, if you're on page 32, look at the middle of the page. Look at part B. It says in 1909 the Pittsburgh Pirates scored 733 runs, gave up 619 runs. How many games did it win? Well, 95 is what the formula gives you. And let's see how many they actually won. I'm trying to see if it shows anywhere. I hope that it does, because it can be pretty accurate sometimes. But anyways, okay, well, let's get back to the problem. So have your books open to page 32, and let's go ahead and take a look at this problem, okay? Now, first of all, let's do part A. If you're looking in your books, and somewhere in your notes, I would put down page 32, example 2. I would write that down so you know where you got it from. But anyways, part A says solve for W. So we're going to solve for W. Got it? We're going to get W all by itself. Step 1, simplify both sides. Nothing we can do to simplify that. Oh yes, there's Mr. Hart. We can reduce. We can cross those off. Oh, please don't do that. But, cross it off. And no. Not when there's 2 terms down here. Don't ever forget that. I'm telling you now, so you're responsible for it. Don't ever forget that. You cannot reduce fractions. Algebraic rational expressions, fractions, if there's 2 terms in the top or 2 terms in the bottom. Now, if it was like this, r squared over r squared, a squared, and there was a multiplication sign here, no problem. This is how many terms here? 1. How many terms here? 1. Remember, it takes a positive or a negative sign to make a term. If there's a plus sign here or minus sign here, then you have 2 terms. Now, if it was multiplying, then yes, you could cross those off, and you'd have 1 over a squared. But never, ever, never, ever reduce a rational expression, or in other words, an algebraic fractional expression, if there's 2 terms up top or 2 in the bottom. Now, there are exceptions to that, which you'll learn later this year, but not for now. So there's no simplifying I can do here. There's no simplifying I can do here. Moving on. Next, we're going to eliminate fractions and decimals. Now, this is something new. We do have fractions, okay? Now, I've taught you in the past, if you have something like 1/2 x plus 5 equals 2/5 x, I taught you one denominator is 2, one denominator is 5. So the common denominator for 2 and 5 is 10. You would multiply the entire equation by 10. I taught you that. It's a little different with abstract equations. So students, to eliminate these fractions, here's what you do. Instead of looking at both denominators, you take it one denominator at a time, okay? So my first denominator is r squared plus a squared. So I'm going to multiply this entire equation by r squared plus a squared. Take some really good notes. It's a tough problem. Do you see where I got this from? From right here. Whatever your denominator is, multiply it times everything. So this over this times this. This whole expression here, even though it's 2 terms, this whole binomial is identical to this one, so you can cross off the whole set. Look at it like this, like there's parentheses around this whole thing, so cross this off, 1 times r, there's a 1 here, 1 times r squared is r squared, 1 times 1 is 1, so you're left with r squared over 1, which is really r squared. Now, next we take this fraction here times this over here. Now, top times the top, that would be w right here times this top. I would definitely put parentheses if I were you, okay? Got it, students? Okay. 1 times t is t. Okay. We're doing pretty good. We got rid of one fraction. Now, look at the next fraction. There's a t down here. So now multiply your entire equation by t. Okay. Now, they're not all going to be this hard. So some of you, I know there's like 4 of you who were in Direct 2 last year, relax. You can do this. all going to be like this. This is one of the hardest ones we'll do, okay? T times r squared is t r squared, okay? Then t over 1 times this. Your t would cancel with your t, leaving you with just this right here, okay? So we're left with w parentheses r squared plus a squared, okay? Now, let's just stop and look this over for a second. I've simplified my sides. I've eliminated fractions. There's really no more simplifying I can do. Yes, there is, Mr. Earhart. You can take this w and multiply it through, okay? Feel free to do that, but you're really hurting yourself because, look, in the end, what are we trying to get all by itself? W. Isn't w multiplying by this? Isn't that accurate? Isn't w being multiplied times this? Sure it is. So could I not just divide both sides by r squared plus a squared and be done with it? I mean, learn to think ahead, guys. These students, these steps are here to help you. But also you can think outside the box sometimes. Now, Mr. Earhart, you're totally contradicting yourself. You're dividing by this, and you're going to cross those off and say we're left with w, okay? And you told us about 5 minutes ago, never reduce when you have two terms in the top or bottom. That is correct. And I also told you there were exceptions, but look, this is different. This is the entire two-term expression identical to this entire two-term expression. So we can cancel those. What I'm referring to is doing something like this up here, where you take part of the binomial and cross it off with this up here. You cannot do that, okay? Now, what I'm simply suggesting is this. I'm saying when you get to this point here, and you see step 3 says simplify again, you can take the w and multiply it through, but it's going to make the problem a lot harder, and I would recommend that you don't do that, okay? I would just recommend that you recognize that you want to get w by itself, so divide this side by r squared plus a squared, but what you do to one side, you have to do to the other side. Now watch carefully. This whole binomial means two-termer. This whole binomial here cancels this binomial here, left with w. Now over here, this would be a situation where you cannot go like this. Do you not see the difference, guys? Here we're canceling the entire binomial with an entire binomial, okay? You cannot take part of a binomial and reduce it with part of a monomial. This is one term up here. You cannot do that, okay? And by the way, if you had r squared plus a squared over r squared plus b squared, and you're like, oh, binomial, so I can cross my r squareds off. No, it has to be the entire binomial. It has to be identical to this binomial, then you can cross them off, okay? So there's no reducing over here I can do. None whatsoever. So my answer is t r squared over r squared plus a squared, okay? Now that would give me the answer for solving for w, so I'm not totally done with the problem, but I've completed part A. Part A said to solve for w, so there, I've solved for w right there, okay? Now, I'm going to get rid of all this so we have room to work. Get rid of this here. And now let's use this here for the rest of our problem. Okay, let's continue on. Take a look at part B. Now, part B says, in 1990, the Pirates scored 733 runs and gave up 619 runs. How many games did it win? We're going to estimate. Now, if you'll look up, now listen to me carefully, look at your book. I probably should have taken a picture of this and put it on the screen, so I apologize for not it tells you, I believe, what the variables stand for. Okay, yes. Top left, black small print, fifth line down, it says capital R is the number of runs scored. So capital R is the runs that you scored. Okay, all right. Read on. It says T is the number of games played. Oh, I missed capital A. Sixth line down, it says A is the number of runs allowed. So A is the runs that you allowed. T is the total number of games. Got it? Okay, so W is the number of wins. So we're going to take this formula and we're going to substitute numbers in and we're going to see what the answer is. So T right here, total number of games, 162. 162. R right here, R squared, R is the number of runs you scored. And if you look at letter B, part B, it says in 1990 they scored 733 runs. So 733 squared all over R squared. So 733 squared plus runs allowed. Well, letter B says they allowed 162 games. No, they allowed 619 runs. Sorry about that. 619 runs. Now let me grab my handy dandy calculator. 733 squared. So if you first take, now listen carefully, do you first multiply 162 times 733? No. We've talked about this quite a few times. You first do your powers, then whatever you get, multiply it. So with your calculator, if you type in 733 squared, or in other words, 733 times 733, you will get 537,289. Then take that times 162, and you will get this right here. 87,040,818. So again, you took 733 squared times this right here. Now down here in the bottom, 733 squared, of course, is 537,289. 619 squared is 383,000. I'm doing all of this in my head. I'm so good with math. I'm kidding, of course. 383,161. So if you square this, you'll get this. Square this, you'll get this. Now add those two numbers together, and what you'll come up with is 920,450. Now with your calculator, take the top number, divide it by the bottom number, and you should get 94.56, which rounds to 95. So the approximate games they should have won is 95. Okay, so there we go. And that's it, students. Okay. Or no, we have one more problem. Sorry, one more problem to do. So that was a little more difficult, but you're okay, guys. It's good for you to work the more difficult problems. One more and we're finally finished. Okay. We have yet to solve a problem in which we have factoring. So let's try one of those. Take some really, really good notes, please, and then we'll be finished. All right. And here we go. And make this 2x squared, please. 2x squared, okay? 2x squared. And here we go. Let's solve for x, all right? Step 1, simplify both sides. Well, you cannot simplify 2x minus 3y. They're different terms. Over here, though, we can take a negative 4 and multiply it through. So negative 4 times positive 2 is a negative 8x squared. Okay? Negative 4 times negative 7. Again, use your calculator if you need to. Negative 4 times negative 7 is a positive 28. Step 2, eliminate fractions and decimals. There are none. Step 3, simplify again. I cannot simplify. Next, move all terms to one side that contain the variable you're solving for. Now, I'm solving for what? X. This term has an X. This term has an X. So I want to get those two terms on one side. So I'm going to leave my 2x here and bring my negative 8x over and make it a positive 8x squared. Got it? Okay. Now, move everything else to the other side. So my 28 stays here. Bring your negative 3y over and make it a positive 3y. There. All of my terms that contain an x are on this side. All the other terms that do not contain an x are on the other side. Now, simplify both sides. Get a lot of you like, oh cool, 10x cubed or something like that. No, these are unlike terms. One is an x term and one is an x squared term. They are not like terms. They are different terms. Over here we have a constant term and a y term. They are unlike terms. You cannot combine them. So there's no simplifying we can do. Now here's where the factoring comes in. If you will listen very carefully, I will explain this to you very well. Let's go back and look at previous problems. When we got to this step right here, and we're solving for y, I only had one y term here, so I just divided by 2, correct? Do you see that? I only had one y term. Look at this problem here. When I got down to the very end, and I was solving for x, I only had one x term, didn't I? See that? So all I had to do was divide by 5. Same thing here. But when you look at number 5, look guys, we have an x term here and an x squared term. We got 2 terms over here. We have a problem, alright? So what we're going to have to do is factor out or pull out an x, okay? We're going to pull out an x. Sorry students, a little interruption there, but anyway, so what we're going to have to do now is we're going to have to factor or pull out an x, okay? Now notice I have one x here, I have 2 x's here, so I cannot pull 2 x's out. There's not enough here. But both of these terms have at least one x. This one has 1, this one has 2, so I'm going to pull an x out, okay? Now, when I pull the x out, I'm left with 2 plus 8x. I mean, think about it. I had one x here. I pulled it out, so I have none left. I have 2 x's here. I pulled out 1, so I'm left with 1. Look at it again, guys. Back up the video and watch again if you need to. Now, if you're, freaking out, there are so few of these we're going to do. Probably, maybe even none, okay? But I'm just trying to show you what to do in these situations. Okay, I might throw one of these at you on a quiz or a test, but these will be not the norm, okay? But having said that, look again at what I've done here. I pulled out an x, there's none left. Pulled out an x, I had 2, now there's 1. By the way, you can check your work. Take this x and multiply it back through. X times 2 is 2x. X times 8x is 8x squared, so it does work. Now I'm trying to get x by itself. I know there's an x here, but I'm trying to get this x here all by itself. So divide by what? Divide by the entire binomial. But what you do to one side, you must do to the other side. So you're finished. 28 plus 3y over 2 plus 8x. Okay? So there we go. So there's an example of when you have to factor. When you come down to your last step where you want to divide by the coefficient and you have 2 terms, sometimes you have to factor out the variable that you're solving for. Okay? That's it, guys. Hope this video was a help to you. If you have any questions, don't hesitate to call or email.